guys, happy Tuesday. Today we're going to talk about the movement and storage of water on the earth. And really specifically, we're going to be looking at mostly freshwater on land, not so much the oceans, although we have talked about the oceans a little bit previously. So we want to understand how water cycles on the earth. And if you took biology at Rocky, hopefully you learned a little bit about the water cycle in that class. So what I'd like you to do on your student response sheet is you can double click the picture, you can drag the words for the phases of the water and show me where the different phases of the water are. And then just write me 2 or 3 sentences kind of explaining how water moves and how energy plays a role. So there's the sun, right, and it's providing all the energy that drives this process. So go ahead and pause the video and do that. And we're back. So you can identify liquid water in these streams, in this pond or ocean, and then we have evaporation happening. So you label evaporation on this red arrow, and this is transpiration when water evaporates from plants. But in both of these cases, the squiggles are representing gaseous water, and then we of course have lots of gaseous water in the atmosphere. When that gas condenses, so condensation on this top red arrow, we get rain clouds, and that can cause precipitation. If we see rain or snow on top of a mountain, we also often have glaciers on top of mountains, and so we might see some solid water on top of there as well. Moving on to this next part, we're going to look a little bit more at these different stages. And so we've got letters representing the different parts, and you'll be responding to some prompts in your student response sheet. So first of all, what is the difference between a reservoir in the water cycle and a movement in the water cycle? So looking at these letters, identify one of each. And then which letters in the diagram represent movement? And which reservoirs do you think hold the most amount of usable fresh water? So that's snowpack or rivers or lakes or groundwater. Groundwater is kind of represented down here by letter F. So go ahead and respond to those, and then we'll talk about them. So reservoirs on the earth are where water is stored. And so water is stored in literal lakes and reservoirs and the ocean. It's stored in snowpack and glaciers. It gets stored in ground water as well, beneath the ground. Our letters that are representing the movement are G, B, C, and D. So we're showing we've got water movement and groundwater flow, we've got evaporation, condensation, precipitation, and then we have the flowing of rivers above ground and below ground. The largest freshwater resource on the earth is our snowpack, which includes our glaciers, and a lot of different parts of the world get all of their fresh water from glacial runoff and snow runoff, and that includes our community as well. So the way we talk about water is we talk about watersheds, and a watershed is an area of land that drains to a body of water. So all of the surrounding area, when it rains or it snows, all of the water goes to one place eventually. So an example of that is the Poudre watershed. There's a lot of places, the upper Poudre, and a lot of places surrounding the Poudre River that drain to the Poudre. And so we live in the Poudre watershed. And so this is kind of a drawing of the borders of the Poudre watershed. So everything within these borders drains into our Poudre River. You see Red Feather Lakes up here, Livermore, and then Fort Collins, and even down to Greeley is actually included in the same watershed. So where do you think our water comes from? Our water comes from the Big Thompson. So a lot of the water, almost all the water basically that is in Horsetooth Reservoir actually comes from the Big Thompson River. And so Big Thompson is a really important water source for us. And then of course we have the Cache la Poudre watershed as well, and that's another big source of water for Fort Collins. And the Cache la Poudre is a really large watershed. It includes parts of Colorado and Wyoming, and there's 6 counties that are included in it. So Grand County, Jackson County, Larimer County, Bald County, Albany County, and Laramie County are all included in the Poudre watershed. And eventually, the Poudre flows downstream to the Middle South Platte Cherry Creek watershed, and that's down kind of near Denver. So if we want to take a more specific look at the Colorado Big Thompson project, we can think about how does the water get transported to Horsetooth, and why do we need to bring water from Grand County to Fort Collins, and then where are we storing that water? So pause the video for a second, talk about that, and then we will continue discussing that. Okay, so if we look at this over here, we have Horsetooth is down here, and then we can look up here. There's like Lake Estes, Mary's Lake, Rocky Mountain National Park, and we have a bunch of pipelines and canals, so these red dashes and the solid red lines, that transfer our water to Horsetooth Reservoir. So the water that goes into Horsetooth is in man-made canals. It's not a naturally occurring river, and Horsetooth is a man-made reservoir. So that reservoir hasn't always been there, and there's actually remnants of a town that used to be there before it was flooded. And so, you know, if we recall, we're in that rain shadow on our side. We don't get a ton of precipitation, and so it's pretty dry. And so we have to transport a little bit of extra runoff, a little bit of extra snow runoff from high in the mountains, snow runoff that normally would actually go. So you can see this is this yellow line's the continental divide. So this is water that normally would flow to the west, and so we pull it over to the east so that we can have it and have enough water. And all of that water is really getting stored in Horsetooth Reservoir, but you can see that there's a lot of other little reservoirs as well. So Flatiron Reservoir, south of us, Boulder Reservoir, and so all of those man-made reservoirs as well are water storage that we've created for ourselves. So there's lots of components of a watershed, and these are going to be important because you're going to be drawing your own watershed. That's the second part of this assignment. So the first component of a watershed that we'll talk about is a snowpack. And this is a reservoir. This stores fresh water for us, and it serves as a water source and natural storage. And if you've ever been in the mountains, even in the middle of summer, you can oftentimes find snow up there. And this snowpack serves as a storage for water year-round. Glaciers are typically even more permanent water storage, and so they're so heavy. There's been so much snow layered and layered and layered that it starts to recrystallize and make ice because it's so heavy, it's just being crushed in the ice. And glaciers are really powerful agents of erosion. They change the face of the earth when they move, and they're so heavy that they get pulled down the slope under their own weight. And glacial calving is when ice chunks break off the end of a glacier. And if you want, you can watch this clip. We watched this in class together as part of Chasing Ice. It shows that huge chunk of glacier breaking off into the ocean. One source of concern right now is as our climate is warming, we're losing a lot of our glaciers. And so normally a little bit of glacier will melt and it provides water for a community, and then in the winter it refreezes and it grows either larger back to its normal size. But what's starting to happen is that they can't recover during the winter, so they're melting a lot, and then they might refreeze a little bit, but not enough. And so if you look at this glacier in Glacier National Park, in the 40s, it was very large. And now if you look at the same glacier, this was even in 2006, so that was, over 10 years ago. And this is all a lake, and the only part that's a glacier is right here. This is still a glacier, glacial ice, but all of this is actually water. And so basically that whole glacier has melted. And so if a community was relying on that glacial water supply, right, there's nothing left now. And they're gonna have to find a new water supply. And that's one of the reasons we're really concerned about the glaciers melting. That, and of course, right, they have a ton of albedo, because they're white, and so they reflect a lot of the energy back into space. So when we lost that glacier, we have a lot more energy being absorbed by the surrounding rock. Okay. Oceans are another significant reservoir, but they're salt water. So it's not water that we can use to drink or cook with unless we do something to remove the salt first, which is a really difficult process. So over 70% of the Earth's surface is water, and the ocean is 97% of the Earth's water. So we have a ton of water, but salt water isn't really useful for us. And so that's why our freshwater sources, that 3%, is so important. Lakes are another natural, or if it's a reservoir, a man-made water storage. So we have an example here. We have Horsetooth on the left, our Horsetooth that we know and love. And then to the right is Dream Lake in Rocky Mountain National Park, which is a natural reservoir. It's so beautiful. The water is so clear. If you ever have a chance to hike up there, I definitely encourage it. And so these are really important components of the watershed as well for storage. All right, so the next part I want you to think about is what a water table is and what parts of the US would have a high or a low water table. So an aquifer is a permeable rock that contains groundwater. So it's a rock, it's solid, but it has like microscopic little holes between the particles. And so water, tiny little water molecules can travel through them and sit in there. And so this is actually a type of reservoir as well that's underneath the ground. And groundwater is subsurface water in a zone of saturation. So that just means subsurface, it's below the ground, and saturation just means it's full of water. And this is why we can often drill wells down and access water through the bottom of a well. So 98% of our fresh water is actually below the Earth's surface, and that's why water wells have been so important historically. All the pores and spaces below the water table are filled with water. And so often if you dig down a little bit, there's no water. But if you dig down to the water table and below, there's a lot of water. And that's how wells work. All right, respond on your student response sheet. This is, time is up on this part of the video recording. So I'll continue these notes on a second recording. Thanks, guys.